Mr. Wizard.
Oh, hi, Irene.
Hi. What are you doing?
Well, I'm just finishing up checking out one of the experiments that you and I are going to do today by cooking something in that little tin can there.
Oh, well, here.
What's this?
Fudge told me to make.
I didn't tell you to make any fudge.
You did, too. You told me to make some fudge.
Oh, no, what I said is, have you ever made any fudge? And you said no, and I said, well, I think you ought to.
Oh.
I didn't mean necessarily that you had to. That's it. Can I eat it?
Sure. What do you mean, can you eat it?
Well, I don't know.
Good?
Mm-hmm. A little sugary.
I hate to tell you who did that.
Very good. Mm. Well, the reason why I suggested that maybe you make some fudge and why I was doing that experiment was today I'm going to play a terrible trick on you. Come over here, I'll show you. I'm going to have you be an analytical chemist.
Mm-hmm.
The problem that you're going to have to solve is what is the proper sequence for putting these signs in front of these three containers of powder. You see that?
Mm-hmm.
From your rough guess, how would you say they go?
Well, I'd say that, I think maybe this is sugar.
Sugar would go in the sugar
salt.
bowl, yeah.
And then I'd say that's salt, but I don't know what hypo is.
Well,
So, well, the only one left.
the only one that's left is that. Well, I'll tell you right now that you're not right. That you're wrong. And before you leave today, you have to do a series of tests or somehow determine which one is which. And in order to show the courage of your convictions, once you have decided, you are going to have to take the one that you finally decide is sugar.
Oh, put it into a lemonade.
Yes. In other words, just the lemon by itself would be pretty sour.
Mm-hmm.
And obviously, of these three things, sugar would be the best.
Mm-hmm.
Okay. Now, of those three ingredients, which one are you going to put on this?
I wouldn't want to put sugar on there, and I don't know about hypo. So I'd say salt.
Salt. Well, now, if by any chance you make some kind of error and you should put hypo on the egg or in the lemon juice, let me read what hypo is. You said you didn't know. It's really called sodium thiosulfate, and it describes it here in this book. And then it says, use as an anti-chlor in the bleaching of paper pulp, as a fixer in photography, for the extraction of silver from ores, as a mordant in dyeing and printing textiles, reducer in chrome dyeing, the manufacture of leather, bleaching bone, straw, ivory, and also as a reagent in analytical chemistry. Now, its medicinal use is for cyanide and iodine poisoning, for the prevention of spread of ringworm of the feet. For veterinary use, it's externally used for ringworm and mange. Now, that's what you will be eating if you put hypo on the egg and put it in the lemonade.
I don't want to.
Well, all right, now, how are you going to decide which is which? There's your problem.
Well, they all look more or less the same.
Well, let's take a closer look at them first.
Okay.
Here's what I've prepared for you. Here's a piece of black cardboard, and I put A, B, and C on it for you. You want to take some of A, B, and C and put it down here on the black cardboard and take a real close look at it. See what you... See?
B. Here's A.
All right. Does that help any?
Well, I think A is... They're small particles, but they're kind of big or uneven or something
Okay.
like that. And now B is much finer. B is very fine, small little particles.
Mm-hmm.
And C is the same way. They have, it's very small particles compared to A or B.
Yes.
And sugar and salt are very, very fine particles.
Okay, so what is C, do you think?
Well, it's either salt or sugar.
Yeah, and B?
B is either salt or sugar.
Yeah.
And I think A might be hypo.
Okay. So at this point, if you put a teaspoonful of B in the lemonade, you might be getting salt.
Mm-hmm.
So you don't want to do that.
No.
You're not ready to try it yet?
Uh-uh.
Well, here, another way that scientists have, other than just plain looking, they have of finding out what something is is to dissolve the material in water and let the water slowly evaporate, or let the material get slowly condensed into form crystals. And here are the crystals of these three substances.
Oh.
This one is sugar. I've sprayed them with aluminum paint so that you can see the faces better. This one is sugar. This one is sodium thiosulfate, or hypo. And this one is salt. Now, from this crystal structure, can you look at these things and tell anything?
I can't tell.
Well, let's put these three powders, so-called, under the magnifying glass or under the microscope and see if we can see from the crystal structure whether whether you can find out anything about them. In order to do that, we'll take the crystals and the three powders with us.
Okay.
Okay, you want to take the three powders? Sure. And I have the microscope set up over there.
Uh-huh.
See right here?
Yes,
Here's
it's a little plate.
A little
ABC on
it has a little slide with. I used a piece of thread to form three divisions, A, B, and C, and I put some of those powders right down there between the letters and the center part, so that when I take that and put that up in the microscope,
oh, it'll be magnified.
It'll be magnified down here like that. Okay. Now, because there's too much light in the room to see, I'll have to turn out the light. Now, see, there they are projected down onto the table. A, B, and C. Now, let's take a closer look at these three. Let me move that out of the way just a little bit so we can get a little bit of light. There. There are the three crystals. Now, scientists study the crystals by noticing the face and the angles that the faces meet. See that? Now, this one is sugar. What could you say about it?
Well, it's big, first of all.
Yeah.
It has oblong shapes. They're triangles and polygons.
Yeah, various.
All different kind of shapes, actually.
Well, now they're not really. They're all the same shape, but they're all at different angles because when you grow them, and the size does not tell you too much about it because you can grow a crystal practically any size, well, within reason. But that particular shape, here's this big one right here. You can probably see the angle at which it meets and so forth.
Yes.
It's a rather sharp angle right there.
It's a very sharp angle.
Now, that's quite different than this one. This is the hypo.
Well, first of all, it doesn't matter, but it is smaller,
Yeah.
and there's like lines in
Yeah,
it.
you see those angles that are formed right
They're
in
like
there?
L's.
Right, little L's.
And they're sharp too.
And they're quite sharp angles. Okay, that would identify the hypo. Now here's the salt.
Well, that's in like a cube, a square shape.
They're cubes, like little dice. You know? Okay, well now can you take these three and place them on A, B, or C down here?
Well, I'll try. Well, I think B is salt.
Okay, you want to put the
Because
salt
of-
still there?
They're squares.
Yeah, let's get these out of the way.
Like rectangles, like cubes, like
Well, don't
the way
forget, you
that
see,
is.
we're only looking at it in 2 dimensions. You know, because this is a flat piece of paper. If you project the cube onto a flat piece of paper, what do you get?
Just a
square.
rectangle.
Yeah, a
square.
square. Yeah. So do you think B is salt? How about A and C?
I still don't know them.
Well, now, the reason why you don't know them is that when to use salt or hypo and sugar, you ordinarily grind it up. And that's why you're having difficulty telling these two apart, because these are just particles, little shreds of the crystals as they've been ground up. So this doesn't tell you too much, does
No.
it? Okay, let me turn on the light again.
I still don't want to eat them.
You still don't want to eat them, although you're getting closer. Well, what we really have to do now is do a series of tests as an analytical chemist would do. And here's the way an analytical chemist would proceed. He would first of all go to the whole body of scientific knowledge, and he would say, how can I tell what is what? And he would find that scientists have made a series of tests on lots of materials. They've melted it, they've dissolved it, they've done all kinds of things with it, and they've put all this material here in a big book like this.
They have practically everything in this
Well,
book?
not everything, hardly, but they have quite a few things. It's a handbook of chemistry and physics that tells you all about the physical characteristics of things. Well, now, I've gone through this and extracted some of the information that I think might be helpful. For example, see what it says on there?
Amount that dissolves in 100 cc's of water.
Yes. Now, scientists have taken all kinds of materials and they dissolved it in water. And they found that some materials will dissolve, more of it will dissolve in water than others. In our case of these three, notice sugar?
Sugar, 180 grams.
Grams, right.
Salt, 36 grams. And hypo, 80 grams.
Yes. So we can now dissolve these three things in 100 cc's of water, and I have it all measured out for you. And we find that there are different amounts that will go in, right?
Mm-hmm.
So maybe we can get some information. Now, as we go along, I have a chart all made up for you.
Oh. And sugar, salt, and hypo.
See, and here's solubility. So if we find that sugar is, say, B, well, you put a B there.
Mm-hmm.
If you find that, the one that doesn't dissolve the least, you'll put the proper number in here.
Mm-hmm.
And you see, we're going to do all these tests before you leave.
Okay.
All right. And it's based on this information that you're going to put whatever it is on the lemon juice. So let's be very careful, shall we?
Okay.
All right, first of all, solubility. Let's dissolve A, B, and C in 100 cc's of water, already measured out for you. About 3 teaspoons of each one to start.
Okay.
I'll put A and you try B and C.
Okay. I'll do B.
Rounded.
So, 3. Now C. 1. Small. 3.
Okay, now while we're stirring these up, take a look at this chart. From past experience that other scientists have had, what do you suspect will happen?
That, of all of them, sugar should dissolve the most.
And
then salt will dissolve the least,
Yeah.
and hypo is like medium.
like medium.
Oh, when I made the fudge, I added a lot of sugar,
How do you mean?
and it dissolved,
Yeah.
right?
Right. That's one of the reasons why I thought maybe you ought to do it, because there is a good example of something that you accept in everyday life without thinking, that a lot of sugar will dissolve in water. How much did you put in?
I put in 2 cups, and then my mother put in some extra.
Oh, you think that's why it's sugary? How much water was it? Remember?
No water, milk.
Milk.
3/4 cups.
That's 3/4 of a cup, you see, and you put 2 cups of sugar in it.
Mm-hmm.
And what happened then? Did it get clear?
Yes.
Oh,
It
well.
just,
How are we doing here?
well, I think C is
C is clear?
A and B,
Can't see anything in either one.
yeah, they're more like
So
clear.
far, we found out nothing. So what are you going to put down on your chart?
ABC, ABC,
ABC, ABC, ABC. Now, why didn't what we did come out the way it did on the chart? What would we have to do in order to make it come out more? In other words,
Add more particles?
right, we'd have to add more until we finally put 36 grams of this and 180 grams of that and 80 grams of this. The other thing that would be important is you'd have to check the temperature very carefully. What happened when you heated up the water when you made or the milk when you made the fudge?
Well, it bubbled up a lot.
Well, but you can dissolve a lot more when it gets
Oh.
warm.
Mm-hmm.
Okay. So rather than go ahead and do any more of this, so far we haven't found out anything from what the scientists have. Let's do something else, however. They have also said, what will happen if we run electricity? If we run electricity through various solutions. See what it said?
Will conduct electricity. Sugar won't,
Mm.
salt will, and hypo will.
Yes. Now, in spite of the fact that we can't tell anything about the solubility, let's run electricity through these three. And here's how we can do that. Here's some ordinary water.
Mm-hmm.
And here are 2 wires that you can stick in these various solutions, you see.
What is it, though? Oh, that's electricity.
That's going to be the electricity. And when I turn on this switch over here, you take up one... Here, give me this for a minute. Pick up one of those spoons and touch it across the wires.
Okay.
Yeah.
Well, there goes a buzzer, and a light lights up.
Yeah. So as soon as we know that there's current going through here, why the buzzer will light up, and or the buzzer will light up, and the and the buzzer will... All right. Try it in the water first.
Well, nothing happened.
Nothing happens. So water does not conduct.
No.
Okay. Now try A.
So that conducts. And so,
Yeah. Rinse it off.
now B. That conducts.
Mhm.
Nothing happens with
Nothing
C.
happens with C. Here, I'll turn this off now. Because now you can, I think, get some information.
Mm-hmm. Well, on the chart, it says that salt and hypo will conduct electricity, and 2 of the jars did, and the other one, sugar, Does not.
Okay.
So maybe C is sugar.
Okay, so now what can you put down?
C for sugar.
C for sugar. And what can you put down for salt?
AB.
Yeah, you don't know whether it's A or B.
And AB.
Okay.
It's either one.
So far, if you're going to put anything in the lemon juice and drink it, it's going to be...
I'd try C, but I'm still not sure of it.
Let's try another test that scientists do.
Iodine solution.
Yes. Now, this means that chemists have found when they mix certain chemicals together, various reactions take place. In the case of iodine, if you have an iodine solution and you put hypo in it,
it clears.
If you put salt in it?
No change.
And sugar?
No change.
Okay, so I have
So we should know what hypo is.
Yes, we should know which hypo is. All right, let's take this and our powders and put them over here in the iodine.
Okay.
Now let me clear this out a bit. You want to give me the chart?
Sure.
Because there's a little sort of thin spoon there. You see that?
This?
With a little point on it. You can put that in the powders and put the powders in A, B, and C. See these? Here are the iodine solutions, and they have their marks. A, B, and C. So go ahead.
Okay. A little bit?
Oh, quarter of a teaspoon.
Well, there's A.
Look.
It's clearing up.
Yeah.
Maybe that's hypo.
Well, okay. Check it with B and C.
Here's B. Well, nothing so far. And here's C. Well, nothing happened in B and C, but A certainly cleared up.
Conclusion?
That hypo might be A.
Okay, so?
I'll write down A for hypo.
A for hypo. How about B and C in this case?
Well, they both remain the same, so I'm not sure which is which.
Okay, so what?
B
Could
and
be
C.
A or B or
B and C.
B and C. Now, notice what's happening here. What have you got in this column?
Oh, I have 3 A's here.
But you don't have 3 B's nor 3 C's.
No.
How about over here?
Well, I have 3 B's here.
But not 3 C's or 3 A's?
No. And I have 3 C's here.
Yeah.
Oh, so maybe this is C? Well, you never know.
You don't know. But the point is we're getting closer. You're not quite ready to...
No, I wouldn't.
Well, now notice the next test that I extracted from the handbook
Formula.
was the formula. Yes, when scientists break up these chemicals and find out what they're made of, why, they can express this in terms of a chemical formula. And see what sugar is?
C12, H22, O11.
And?
Salt is NaCl. And hypo is Na2, S2, O3, 5H2O.
5 parts of water in this particular crystal. So now, let us put sulfuric acid on each one of these and see if we can get any information about it. So far, you can't tell much about it just from looking at the powders. Can you anything about this?
No.
Let's try putting some sulfuric acid. Bring the powders over.
Okay.
Here.
Okay.
Because here are little dishes, and in that little bottle here is sulfuric acid. So put about a teaspoon or so of AB here, I'll take. A, B, and C in each one of those dishes.
A. B. C.
All right. Now put, say, 2 eyedroppers full of sulfuric acid. Be careful now. Remember that burns your fingers and your clothes. So.
Okay. Well, it's bubbling.
Yes.
And it's turning a yellow sort of color.
Yes.
Oh, and it smells.
It sounds like it's not roses, the way you're talking here.
No, eggs.
Eggs. That smell you're smelling is a very peculiar odor which scientists would recognize immediately as hydrogen sulfide, and is the smell of rotten eggs.
No.
And it's primarily because the reason you smell it in eggs is that when eggs sometimes get cooked or when they're rotten, they give off hydrogen sulfide too. They have sulfur in them. Okay, now try B.
Well, that's bubbling too, but it's not changing color.
Now this time, put the eyedropper back in there and bring your hand over the top and smell it like that. You smell anything?
Oh, it goes up
Yes.
It chokes you, you know.
You ever smelled that before?
I don't think so.
Chlorine.
Oh.
Chlorine gas. Now try C. Not bubbling.
Well, it's not bubbling like the others, but it is changing.
Changing color.
Color.
Careful with this now. In fact, it's what? Getting kind of a golden brown
It's getting
now.
brownish, and it's getting darker.
In fact, keep an eye on it because it's going to get darker and darker. In fact...
Now it's black.
Yes, it's black. Well, now let's look at the formulas. Any of the, let's start with A. When you put sulfuric acid on A, it got yellowish and gave off a sulfur or hydrogen sulfide smell. Which of these three compounds do you suppose would be A?
Well, sugar has no S in it for sulfur.
Yeah.
Salt doesn't. The only one does is hypo.
Hypo, right there. Therefore,
Hypo is A.
hypo is A.
Yeah. Yes.
And the next one, we got that chlorine gas. Which one do you suspect that is?
Well, salt, because that has Cl.
All right. Chlorine, Cl.
B.
And finally, that black stuff that we got on there?
Oh, well, the only one left is sugar.
Sugar. But just to make sure, was there anything that in this compound here that could be black?
Carbon.
Carbon, yes.
There.
How are you doing now?
Well, I have all C's in here, and I have 4 B's here, and have 4 A's here.
Okay, we're getting pretty close now, aren't you?
Mm-hmm.
Let's do one more. You notice the thing that's on here?
Melting point.
Yes, melting point. Scientists have heated all these things up because heat also will break up compounds. And they've found that when you melt something, the temperature in centigrade now, you see what happens?
Sugar decomposes at 160 to 180, and it gives off a caramel smell.
Mm-hmm.
Salt at a high 804,
Yeah.
and hypo at low at 48.
So let's take those three powders now and put them in 3 little cans. You see, that was the experiment I was checking out when you came in with your fudge. Here are the 3 cans. Let's assume they're A, B, and C like this. Let's put about 2 teaspoons of powder in each one.
I'll do C.
All right, there's A. A, B, and C. Okay, now I'll heat them up with the torch. And if what you say is, if what you found so far is correct, what should happen when I heat up the first can here?
Well, sugar should, if it's sugar.
Yes, but you think it isn't sugar, do you? A?
No, I think that's hypo.
You think it's hypo, so what should happen?
It should heat at 48.
It should melt rather quickly then. Okay, let's try it.
It's starting to, well, it's moving, it's bubbling.
See how it's bubbling and melting already?
Mm-hmm. So that must be the hypo.
Pretty cool. Well, it's a pretty good idea that it melts at
it's another
relatively low temperature. Okay, you want to put then, well, let's try, before you put any more down, let's try the next one. If you think that the second one, let me move it out. You think the second one is what? B is what?
Salt.
Is salt. So when we heat that up, what should happen?
Well, it won't melt until 804 degrees.
Notice nothing is happening to B, but I'm still boiling A next to it over there. Just from the heat next to B. Nothing, huh?
Nope.
Okay, now the last one, C, you think is what?
Sugar.
And what should happen when we heat up sugar, did it say? Decomposes?
Decomposes 160 to 180 and gives off a caramel smell.
Okay, let's try it.
Well, it's bubbling.
Mm-hmm.
It's turning dark, too.
Now, in fact, I'll take the torch away.
It's on fire itself.
So what does that mean? That's decomposing.
Oh, yeah.
It's obviously combining with the oxygen in the air. And notice, do you smell anything? Here, bring your hand.
Caramel.
Yeah, caramel. Now, when you cooked the fudge, what did it say about cooking the fudge?
Oh, a low flame.
Yeah.
In other words, if I cooked it at a high flame, I'd burn it like that.
You'd burn it like that, yes. That's why I thought it might be a good idea for you to make it. Well, now, put melting point. You have got the pencil? Okay, can you now make some kind of conclusions?
Well, the melting point was sugar for the decomposing.
So that
So
was
it was
C.
C.
Okay, so C, that definitely was sugar. Salt,
And then salt, well, it just didn't go.
that was the middle one.
So that's
Okay,
B.
B.
And then the first one,
That melted.
that melted right away.
Yeah.
So that was hypo, probably.
Okay. Are you ready?
Yep.
There we
I
go.
guess so.
Here's A, B, and C.
Okay.
A, B, and C.
C.
Now, let's start with C. Or A, I mean.
A.
You going to put A on the egg or the...
No, I think that's hypo. Because all the tests work out fine. This one,
It dissolved.
solubility,
Yeah, it dissolved.
And it did conduct. And the iodine, it cleared it up. And then with the formula we saw.
We saw sulfur in it, yeah.
And the melting point.
Okay, so you're not going to put in, use C for
No.
anything. All right, now how about B? What are you going to do with B?
Well, we saw it in the solubility.
Yeah,
And it did conduct.
yeah.
And it didn't change in the iodine solution. And in the formulas, we saw
chlorine.
the chlorine. And, well, it didn't melt.
Okay, therefore you think what?
I think salt is B. There's the egg.
Have a little B for your egg.
Oops.
Remember now, in case you have mange, you're going to be all fixed up if that's... Oh, you cheated. Yeah, was it? Okay.
Yes,
Help yourself. If you brought me fudge, I'll give you an egg. You were right. Okay.
I was right.
If that's the case, there's only one left. But just to be on the safe side, because I don't want you to take anything that ordinarily would be used for ringworm, you're going to definitely put C in...
In the lemon, yes.
Yeah, in the lemon. Why?
Because, well, first of all, in solubility,
Yeah,
we
it
saw it.
dissolved.
And in conduction,
Mhm.
well, it didn't.
Mhm.
And in the iodine, it didn't.
Mhm.
In the formula, we saw the carbon.
Yeah.
And then in the melting point, well, we saw it decompose.
Okay. You get C, and I'll cut the lemon up and squeeze it in the thing. You get a good teaspoon of C.
Okay. I'm all ready. Okay.
Go ahead. Squirt all over the place. Stir it up.
Whoops. Now, well, here goes.
Yeah. You right?
That was sugar.
Okay. And now how are you going to line these two up? What was A?
A was hypo.
And B?
B was sugar.
And C?
Was salt.
Congratulations very much, only you haven't
Nope,
turned
yeah.
around. Now you got to thank you very much. You did very well indeed.
Oh, thank you.
Watch Mr. Wizard is presented each week at this time by the Public Affairs Department of the NBC Television Network in cooperation with New York University.